Okay.
Sorry, bro.
So let's talk. Let's see. We did the percentage quiz yesterday, and that's kind of quiz, a worksheet. We'll call it a worksheet. And so now we're going to talk about powers. Powers.
Like shooting lasers from your
Like
eyes.
superpowers. And I've told you what my superpower is.
Writing on the board.
I have night hearing.
What?
Night hearing. What? I can hear at night when it's dark.
Hey.
Unlike you two.
I have no idea.
Andy's half blind.
Okay, let's not pick on Tim. Powers. The power or exponent power or exponent of a number is a shorthand method, shorthand method of indicating how many times a number called the base number, let's say called the base, is multiplied by itself. Where was I? By itself. So for example, we have 3 squared. So 3 is my base number, and 2 is my power or exponent, is the same thing, or we would call that 3 squared. That's the way we'd say it. And it's really 3 times 3. All right, or if we said 3 to the 3 at the 4, we'd call that 3 to the power of 4, or 3 to the 4th power. That's right, 3 to the 4th power, which is the same thing as saying 3 times 3 times 3 times 3, which is what? 81, thank you. All right, now I don't want to do that longhand unless I absolutely have to, so I want to use my calculator to do that. So here we have our calculators. Got my laser pointer. There we go, laser pointer, so Steve can see it back there. Okay, so on this calculator right here, what do we got? So if we're going to do just squares, like 3 with the 3 squared, we have the x2 button right there. And then over here, where do we have an x? There, no.
It's the down left.
Down left.
It's the arrow pointing.
There we go, right there. I told you I'm used to one on my right. You're right too. Okay, so there we get there. But what if I want to do, like I had the example up there, 3 to the 4th? Will I hit that one twice?
No.
Okay, no, we don't want to do that. We have a key right here, y to the x. So on something like that, if I want to do, I know it's 81, so 3 to the 4th power, hit 3, and then hit that yx, 4, and then equals, and I would get 81. Yeah, this one's different. We're going to look for the... There. No, that's not that one. Is it this one?
Yeah,
That one. All right. I don't know who's teaching who here. All right. So 3, that one, yep, to the 4th, equals 81. So everybody got that? If you got this calculator, you can do this one here, and this one over here is this one here. Yeah, where am I here? Oh, we can go in the middle. How do I say this one? What is that?
2 cubed.
2 cubed. 2 cubed. Which is what?
8.
Not the answer. What is it written out?
2 times 2 times 2.
Were you Def Leppard drummer over here?
Yes. Give me a 1
That was a bad joke. I like that guy too. Your arm hurt?
No, it's cold. It's cold.
It's because you took his seat. All right, 2 cubed. Okay, so 2 times 2 times 2, which is 8. Do we know that? Because we can put it in our calculator. We can do the 2. How are we going to do it on the gray calculator? 2 what?
2yx.
2yx to the 3. Right. I would not recommend 2 times 2 times 2 because if you get something with its a power of 5, you got to do it 5 times. You kind of lose count somewhere in there. All right. How about
the number 1 with the green? The second has a cube.
the number 1 with the green? What?
It's second.
Second?
So he has an x3 in the green.
Oh, it does have a cubed.
He has a cube.
Yeah. I got to learn too many buttons. Where's my cube down here?
It's over the number 1.
Over the number 1.
Oh, way down there. Okay.
Yeah.
All right. What is that? 10 to the 5th power. All right. And that is, of course, 10 times 10 times 10 times 10, 5 times. What is my answer there? What would that equal without me having to write it out? I hear one person. How much? Is it 1,000?
Well, that way in case it's wrong, you don't really notice it.
You have to do better than that. I got 6 kids. You don't think I haven't heard that one before?
100%.
Con artists, every one of them.
Why don't you just write down on the board what you have heard, and then we'll come up with the rest.
Yeah, you'll tell us which one is right. How about if I write down the right answer and you tell me if that's what you said?
All right.
All right. X to the 0. Well, what happens if I raise something to the 0 power? What is that going to equal? We could try it with something. I don't know. 2xy 0 equals. Oh, my calculator must be broken because it says it's 1.
Yeah.
Oh, so everybody says it's 1. All right. So any number. Any number other than 0. Other than 0. Any number other than 0 raised to the 0 power is 1. So 10 to the 0 equals 1. What is 0 to 0 power? It's going to say error.
Error.
Error. It equals error.
So will that be
All right. So we know how to use a calculator. We know how to handle that one. What about negative powers? It's like Dennis. He has the ability to repel. You asked for that one, sorry. All right, let's see. Negative powers. 2 to the negative 3rd, so that's 2 to the negative 3rd power. I'm not going to write all that out. 2 to the negative 3rd power is actually 2 to the 3rd 1 over. And so that's 1 over 2 times 2 times 2, which equals 1 over what? 8. So can we do that on our calculator?
Sure.
2, so I'll do the yx, 3 negative on mine, you'll be negative 3 equals, and I get, my calculator says 0.125, but I don't want it in a decimal, I want it in a fraction. How do I convert it to a fraction? Second FD. Wow, you guys are catching on. All right, second FD, I got 1/8 is my answer, which I already wrote down. So negative powers. How about 10 to the negative 5th?
Let me tell you.
The answer's right here.
Can you show how it's on calculator?
Show what?
On calculator which buttons?
Yeah, I'll show you which buttons to do. Okay, so let me go to this one over here. Alt tab. Which calculator do you have? You have, okay, you have this one here on the right. So, so that one would be, what did I put? 10 to the 5th? Negative. Okay, so it's 10, 1, 0. This button right here, YX. Then you're going to hit 5. Then you're going to hit this negative key. Then equals. And did you get the answer?
Yes.
All right, what'd you get? 0.0004.
4 zeros 1.
Oh, I like that. 4 zeros 1. Does everybody agree?
Yeah.
All right. And that's also happens to be the 1 over 10 over 5. So there we go. All right. Just to make things really confusing.
Please.
Negative bases. If we have -2 parentheses 2, that is the same as saying -2 times -2. And that's going to equal what? 4. And I don't know, I think with the other calculator, the 2s, oh no, the other one has parentheses. We can try it that way. So parentheses, 2 negative, no, it doesn't do parentheses.
Yeah, it does. It has it up in the top corner. It doesn't lay it out like the.
Yeah, okay, it has them, but you can't see them. So, okay, that gives me 4 because a negative times a negative equals a
Positive.
positive. All right, so we could do the same thing with -2 cubed would equal -2 times -2 times -2 is going to equal
-8.
-8. See if the calculator agrees, just out of curiosity.
Yes.
-8. Negative times a negative is a positive. Positive times a negative equals a negative. All right, but -2 squared. -2 squared is different. That equals -1 times 2 times 2, which is going to equal a
Oh, negative.
-4. And then we could look at what if I had a -2 cubed is going to equal -1 times 2 times 2 times 2, which is going to equal a -8. So you got to watch if it's in the parentheses. Just remember it's laid out that way. But if it's not, it's
I put the -2 squared.
cubed.
The calculator came up.
Squared?
Mine too, but not negative.
Yeah, for the first
In
one.
parentheses or what?
This one or this one?
Bottom one, but.
You said squared. Squared or
-2
cubed?
-2 squared.
-2 squared here.
Yeah. I put
With or without? Oh, without.
Without the parentheses.
Without. So you just did 2 negative x squared
Positive 4.
positive 4. Well, this is correct though. I have verified this.
My calculator comes up back.
Yeah, I did.
What's that?
So my calculator comes up back.
Your calculator agrees. Which calculator do you have?
Not either one of those.
Not either one. So,
I like mine better.
oops.
She has a fancy calculator.
-2. Let me see.
But if I did like.
Okay, this one agrees. This one agrees with follows the rule. Hey, that is the rule. All right, and I verified that and cross-checked it. And I'm going to stand behind it. So I'm telling you that is the rule.
Why?
Why is it?
Why would you? Why does one have parentheses and one doesn't?
Because the one with the parentheses, I don't want to labor on this point, but the one with the parentheses, because this is what it looks like longhand. It's -2 times -2. Without the parentheses, it's a -1 times 2 times 2.
So the power.
And so that it's always going, this way it's always going to be negative. And this way here, it depends on if it's odd or even.
But you-
Sorry, it's
but
just,
you're doing a -2.
it's the way it is. All right, I'm going to move on from this because that's just all I'm going to say about negative bases.
Just
Yeah.
out of curiosity, how come you put the exponents on the -2 and the parentheses?
Oops, I didn't mean to.
Oh, okay.
I meant to put it here. Sorry.
No worries.
Thank you. All right. Powers of 10. Powers of 10. So we should know this. And 10 to the 0 is what?
1.
1. All right, we'll get back to something that's not part. 10 to the first power is 10. Then 10 to the 2, 100, and 10 to the third is 1,000. All right, so it's kind of, in some ways, it seems a little confusing. 0 becomes 1. The way I look at it is, oops, we can do this one. No, 10 to the -1 is Remember, it's 1 over 10, which equals 0.1. So 10 to the negative 2 is 1 over 100, and so on. All right, so let's see. Could be confusing, but remember, start. Let's see. Start to the right of 1. How's that? Start to the right of 1. To the 1. And just count the number of decimal places to move. So in other words, I had 10 to the 0. How many decimal places do I move? None. So that equals 1. 10 to the, let's do 10 to the second is how many decimal places? 2. I start here, go 1, 2. So I have equals 100, right? 10 to the negative 2, start at the 1 and go backwards, 1, 2. So it's equals 0.01. All right? So just remember that's how it works. All right, how about roots? The root is a number, that when multiplied by itself, a specific number by itself a specific number of times produces a given number. Well, that was really a lousy thing to say. But where I'm going with that is this thing. What is this called? All right, actually called a radical sign. You say, dude, that's radical. Oh, that's what you're talking about. All right, we can also call it square root. And so when I say a square root of 25, what is my square root of 25? 5, which is the same thing as saying 5 squared. So 5 times 5 equals 25. So the square root of 25 is 5. And 5 squared equals 25. So if you can see the relationship there. But how do we do it on our calculator? Well, quite simple. Press the button. All right, so on this one right here, we should be one more. Right there. And we should have one for cubed root.
You have to do this second.
Yeah, second.
Yeah, no, it's second.
Arrow up. On the other one.
Oh, which one is on this one?
Down, right there. Left, arrow up.
There we go, right there. Second function, that one. So, all right, so I want to know square root of 25. I'm going to 25. Hit that little right here.
Is that the right one, Tyler? I think it was the one there.
There's that one.
I'm doing this one.
No,
So,
I'm talking about that
so I do 25, hit that. I'm going to show up with 5. And there was one other key I just lost here. I want to do cubed root. There it is. Cubed root is down here.
That's the second function, right?
Yep. So
8.
So what's the cubed root of 125? So I do 125, second function, right down here, cubed root. I should get 5. Look at that. All right, then over here we've got, where did I just lost it here?
So cube and.
Cubed root is,
Right above each other
what's that?
on that second page.
Oh, I'll go back to it. So cubed root said 125. I would look at, it would look like that. Oops. Froze up. 3. So cubed root. So cubed root of 125 is 5, which is the same thing as saying 5 cubed, or 5 times 5 times 5 is 125. Oh, there it is. So Alt Tab. All right, right here is the little second function, that key right there. So if I wanted to change it to a 4th root or something like that, then you would just punch that in there. All right, so this one, we got
Bottom
All the way
high.
to the left.
square root right there, and
Cube is right above it.
cubed is right above it.
So when you're clicking that in 3, cube,
It's already on there.
5,
It's already on there. This particular one right here, it's already built into the calculator. Which one do you have?
the
Hold it up.
right?
Gray one. Okay, so right here, right above the 0.
Okay.
So hit 125, second function, the 0 key. Got it?
And you can't,
It's on the.
but let's say it's like 4 or 5.
Let's say it's 4 or 5. Okay. So
Yeah, it's the one right with the Y.
600.
so let's do this. 625.
So
Can you solve for that? All right, to solve for that, I have to plug it in myself, that 4 myself. So 625, second function, the second one down from the off, the y over x. 4 equals 5.
You knew that was 5, wasn't it? You knew that. Was it 5?
Well, yeah,
I don't
because
know,
I
you know,
just multiplied that times 5 and did one more. All right, everybody follow? Okay.
Can you like write them down on the?
Yeah, okay, so like
They're helpful, like.
right here. So this, okay, so your calculator, I would do 625. So hit those keys that you're talking about. And then the next key I'm going to hit is
To end.
the second function. And then the x, y, which is also, and it's the small one, which is also the y, x key. And then 4. And then equals. This one right here would be 125. Second. 3 to the x, which is also the 0 key, equals. We good? Now sometimes you get funny things like fractional powers. And fractional powers are actually the same as roots, say square roots. So if I had 4 to the 1/2 power, that's the same thing as the square root of 4, which is 2. And I think we could even do it, let me see, 4 xy to the 0.5. Yeah, that'd work. So you could even do that on your calculator as 4 y to the x, 0.5, well, you have to do the point, then the 5, and then equals, and it'll come out 2. So then we can do the same thing with the cubed root. If I said 27 to the 1/3 power, how would you do that? 27 x, y. See if we can get tricky with this. How far can I drag this calculator down my rabbit hole? 27x. Yeah, that's what I was wondering. 1 ABC 3. Whoa, it does work. Okay, so 1 ABC 3 equals, and you should get 3. So it'll actually work that way. So you just, as long as you know how to run the calculator, you can look at all these things and don't freak out when you see it. Just go, hey, that's not a big deal. 27 and a third power. Oh, there's no third power. So just make it into a fraction just like you already learned. Worst case scenario, if my calculator didn't do it and I was stuck with my phone or something, I would just do 1 divided by 3, figure out what the decimal equivalent it is, 0.333, and then plug that in. But hey, it's not hard, right? Once you figure out how to do this stuff and run the calculator. In some respects, you almost don't even know what it is you're coming up with. It's just, hey, that's the number they're looking for. And there you go. All right, can I move off of this subject?
I'm still kind of stuck on why one calculator is negative and one's not.
Yeah.
Well, one calculator actually worked and one didn't.
This one doesn't say it's negative. It's
Yeah. I don't know where that one comes from.
If I get wrong on the test,
That doesn't make sense.
I get it correct.
Okay.
Alright, we move on
You
now.
know what he's gonna say?
Why did the calculator?
Use both.
So I told you. I told you in class. Yeah.
On this calculator, when you're doing those, the square root,
Uh-huh.
do you just assume it's just square or cube?
Well,
at the
this
bottom,
is-
like a fractional power?
This is, oh, fractional powers?
Yeah.
This-
Do I just put here, square root of 4?
No.
No? Instead of using the fraction part?
Oh, you could, but I wouldn't.
Okay.
I would actually, if I was looking at a test, I was taking a test, and it said, what is 4 to the half power? Now, I just told you that's the same as the square root.
Yeah.
I wouldn't even do it on the test. I'm like, that's a square root, right? Hey, I'm not going to risk it. I would actually put 4, 1, ABC 2 equals, and we come up 2 and go, oh yeah, that's right. I would actually plug it into the calculator just as it's written here, just so I wouldn't make a mistake.
Okay.
That's just the way I work. All right, scientific notation.
Oh.
All right, so that is shorthand. Shorthand used to express very large or very small numbers. All right, the number has 2 parts. What's the first part? I need my Cricut app.
This was Monday's project.
First part is, I know, that's actually why I don't mind going over it. First I think, oh, they've already done this in lab. And I'm like, yeah, but that was yesterday. The first part is the base number. First part is the base number. What is the base number? The base number's got to be greater than or equal to 1 and less than what? Very good. Less than 10. So I could have 1.0 all the way up to 9.999 or something like that. But it has to be, the base number has to be between these two. I can't do an exponent like 10.2 because it's too big. It's got to be, I don't know who made up this rule, but that is the rule. You can actually write it incorrectly, and you'll see it written incorrectly, and you should be able to go, oh, I know what they mean. But proper is this way. So second part is the power of 10. Is a power of 10, I like the letter. Is a power of 10. So for an example, I could put 2.35 is the first part, meet the Meet the code?
Yeah.
Okay, 2.35 times 10 to the 6th power, right? Which is the same as saying 2.35 times, what number is this here? 10 to the 6th power. What's that?
1 million.
How many zeros?
6.
Well, I didn't know. I could just put a whole bunch of them, and I could say, well, I start where to count? In front of the one, to right of the one, and I count over 6. 1, 2, 3, 4, 5, 6, right there. So 1, 2, 3, comma, 1, 2, 3, comma. So that comes 1 million, right? So it's really just 2.35 to that. And it works out nice. Let me see. Speed of light. What's the speed of light?
300,000 meters per second. Not that.
Meters. We did not beat the British during the Civil War to to be speaking about metric system. Okay, everything I just said about that was wrong, so I know that. All right, speed of light. 6. I have to write it. 670 616. And I'm just as an example. Please don't try and remember this. Miles per hour.
Wait, that's the speed of sound.
Oh, not hour. Is it miles per hour?
A second.
That's gotta be seconds. Miles per second. Well, I timed it. I got Tim. He got down there with a flashlight and I had a stopwatch. Ready? Go! All right. All right. And so I don't want to. That's not that bad of a number. What would that be in scientific notation? Well, first of all, we got to have the decimal at which point?
Right after 6.
It's got to go there. So 1, 2, 3, 4, 5, 6, 7, 8 spots over. 8 spots over. So it become 6.71, if I want to stop there, times 10 to the, how many places did I count over?
8.
Times 10 to the 8. I forgot 2, that's why I was asking. All right, so it's just an easy way to write something like that. What if I want to write it really small? Let me see. If I had a number like 0.00000235. What would that be? Well, got to move it 1, 2, 3, 4, 5, 6 places. So 2.35 times 10 to the what? Negative 6.
I had a question from the Q&As.
Oh, that's right.
Yeah.
Yeah.
There was a question that said, what is the power of 10 equal to 1 billion? And do you want to write that one out? What is the power of, so what is the power of 10 is equal to 1 billion? So is it 10 to the 9th, 10 to the 10th, 10 to the 6th? And I couldn't.
Oh, you actually got it.
Yeah, I brought it up.
All right.
I brought it up.
Let me get back to that. Hang on to that.
Okay.
Here's where
Well, why?
people get messed up.
Okay, good.
All right. So if I have a number, we can just use the same one I had. Let me go back to black here. 2.35 times 10 to the negative 6. Why not? And sometimes people will look at that. Now, if I'm going to give you some answers on a test, multiple choice, I guarantee you one of them is going to be 0.00000, if I get the right amount of zeros there, 235. I'll say, oh, that would be A. And then B is going to be 2350000, something like that. I'll have the right amount of zeros. I didn't count them real quick. 0.00. I think there's one more zero in there. Anyway, I'm going to give you these options. How do you know right offhand which one it is? Okay, so first of all, what I say is you got to look at this and you have to unpack it. Okay, unpack it. When you unpack this number, and what I'm saying is converting it to something, to these numbers over here. When you unpack it and you see that -6, it must get what? Bigger or smaller?
Smaller than 1.
Smaller. You have to remember that this number is going to get smaller. And if this is a positive number, it's going to get bigger. So 2.35 times 10 to the 6th. That's a positive, so it's going to get bigger. So start right there. Say, okay, is this number going to get smaller or is this number going to get bigger? Bigger, G-G-E-R, didn't work out well. Bigger.
That looks like 8.6.
I know, it really got nasty, didn't it? I had to start all over again. There, bigger. Okay, so that number has got to get bigger. So this one's going to correspond to that one, and this one's going to correspond to that one. So remember that. Always remember that. All right, now, if you don't want to write it out on your calculator, like if I had 2.35 times 10 to the 6th times 6.39 times 10 to the 9th, there is a way, and I could take some time and show you how you could actually add the exponents, but I like to keep it simple. One way of doing things, you can actually put this in your calculator. Very simple. So it would be 2.35 in my calculator, 2.35. And this particular one is going to be the, oops, stop it. EE 6. So 2.35 EE 6 times 6.39 EE 9 equals. And that's going to give you my answer.
1.5016.
Quite simple, wasn't it? All right, now if you have the other calculator, you don't have, the EE key is buried just a little bit. It is right here, the X minus 1 key. And by the way, the X minus 1, and we're going to get into this, X minus 1 on this one is the 1 over X key on this one. So we're going to be using the 1 over X, X minus 1, EE, and EE quite a bit. All right, you good on that one? You know how to find your EE key? You know how to use the EE key. All right, what if it was to the negative? So 2.35 times 10 to the negative 6 times 6.39 to the times 10 to the negative 9. What if I would have wrote that? How would I punch that in my calculator? Okay, same way, but just use negatives. Okay, EE 6 negative on the gray calculator. On the pink or blue one, 2.35 second EE. We have to go negative first. 6. So that is the gray. This is the blue. Oops. 2.35 second EE negative, then 6 to get that. And follow suit right down the line. So now we can take these powers that we're talking about here. I didn't lose anybody yet, did I? This is your cue to raise your hand and go, yeah, on day 1 when you're talking about the plus sign again? Yeah. That's okay. I actually had a student, one of my favorite students, who, anybody lost? Raise your hand. Yes, I'm lost. Okay, where did I lose you? Right after we walked in the door and started the class. Like, are you serious? Yes, I'm serious. I said, who else is lost? And like a couple of hands go up. So, one brave person saved the whole class. All right, so we're dealing with these exponents. And I touched on this the other day. And I said, well, I'll circle back around to it. These exponents times 10 to the whatever power correspond to prefixes, and we give them names, such as tera, which is 10 to the 12th, giga, which is 10 to the 9th, mega, stands for Make America Great Again, 10 to the 6th.
You've been waiting all day to say that.
No, I really just came in. If I would have really thought that through, I wouldn't have said it, trust me. Kilo, 10 to the what? 10 to 3. All right, so I'm going to do this. All right. Wouldn't want you to have to memorize all of them, but there's some that, boy, you really we're going to have to memorize. Hecto, 10 to the 2nd. Deca.
I'm assuming it's the 4 that were in our packet.
What's that?
So I'm assuming it's the 4 that were in our packet. I mean,
The 4 in your packet?
yeah, on the first day. Pico. There were only 4 in there. There were Pico, Kilo,
Okay.
Mega.
I don't remember the packet. Okay, Millie, here we go. Millie.
Yeah, Billy was one.
Yeah, Millie's one. Millie, 10 to the what? Well, -3. All I have to do is follow my order. Millie, micro. M-I-C, micro. 10 to the -6. Nano. Now that I think about it, I miss my nano. And pico. 10 to the -12. All right, so which ones do we have to remember? Kilo, milli, micro, pico. Kilo, what is the abbreviation for kilo?
Okay.
Capital or lowercase?
Capital.
Big K.
I think it's lowercase.
You're the teacher.
That's not
I don't know. Huh?
That's not what was in the packet.
What packet are you talking about?
The one
The lab
you
sheet.
gave out.
Lab sheet.
Oh, the lab sheets. Oh, good Lord. All right. I do think it's a big K. I think my notes right here are wrong. Because everything up there is big. Milli. Little m. Micro.
Big M.
Pico's the U, isn't it?
It's the mu.
It's the mu. And pico. Little p. Little p. All right. So you need to remember those. And you need to really commit them to memory and be ready to go with them. All right.